Hello everyone and welcome to the PACE Center classroom. My name is Stephanie. In this program, we'll explore the challenging world of electronic assembly and repair. Today's advances in electronics depend on your ability to perform a wide variety of assembly and repair tasks, both safely and effectively. This requires not only the right equipment, but more importantly, proper technique, which can only be gained through training and practice. Remember, you make the difference between success and failure. In this presentation, we'll cover the basic operation and maintenance of your PACE Sensitemp handpiece and system. For further details, consult the printed manual provided with your handpiece or system. A number of different techniques will be presented, so be sure to use those techniques which conform to your organization's standards. And finally, be sure to follow all personnel safety and static control requirements before you begin to work. Let's get started.
The TT-65 ThermoTweez is one of a family of PACE Sensitemp handpieces, which operate from any PACE Sensitemp power source. The ThermoTweez provides safe, rapid removal of a wide variety of surface mount components in a simple one-handed operation. Remove SOICs, SOTs, PLCCs, chip components, and others without damage. The ThermoTweez may also be used for realignment and replacement of some components. The ThermoTweez's low temperature, high capacity heating can remove even the largest components quickly and easily. A wide selection of standard tips meets the industry's requirements for today's electronics. New components and applications require PACE to continually develop new techniques and capabilities. Custom tips for specialized applications are available. See other PACE videos for surface mount LAN preparation, soldering, hot jet installation, and removal of other component types. In Part 1 of this presentation, we'll discuss setup and tip installation for your ThermoTweez handpiece. In Part 2, proper tip selection for various applications will be covered in detail. Part 3 deals with selecting a proper tip temperature for your particular application. Part 4 examines handpiece, tip, and work preparation. In Part 5, we'll learn basic component removal technique for your ThermoTweez handpiece and the safest, easiest ways to remove large components from extra heavy boards. And in Part 6, we'll learn important routine maintenance for your ThermoTweez handpiece and tips. First, insert the line cord into the AC power receptacle on the back panel of your system. Then into a properly grounded AC line receptacle. The patented ThermoTweez handpiece features an adjustable hinge and tip gap adjustment, which allow you to achieve perfect alignment of the tips, a critical feature for safe, rapid component removal. To confirm alignment of the handpiece, turn the tip gap adjustment thumb screw until the heaters are parallel. If the heater ends are even with each other, you can proceed with tip installation. If not, loosen the hinge screw half a turn with the tip tool. Then gently press both heaters against the tip tool itself until the heater ends are even with each other. Finally, tighten the hinge screw. The ThermoTweez is installed on the front panel of your PACE SensiTemp system. First, align the connector key with the receptacle keyway and turn its locking ring fully counterclockwise. Now insert the connector key into the power receptacle until it stops. Then turn its locking ring fully clockwise to secure. When using multiple handpieces, colored markers are helpful to identify which handpieces are connected to which channels. We'll now review the proper method for installing tips into your ThermoTweez handpiece. To ensure proper fit, always install tips into your ThermoTweez when the heaters have reached an appropriate tip temperature. Setting the tip temperature will be discussed in detail later in Part 2. There are 3 basic methods for installing tips into your ThermoTweez, depending on their size and type. To install chip component tips, insert the tip halves all the way into the heaters until they bottom out. Next, position tip ends so they meet precisely when the ThermoTweez handles are squeezed together. The heater set screws can be tightened very slightly so that the tips stay in position when being aligned. Then gently tighten the heater set screws to secure tips in place. For small PLCC tips, follow the same procedure. Make sure they have reached solder melt temperature before alignment and tightening of the heater set screws. For SOJ and connector tips, follow a similar procedure, but first open the tip gap further apart and squeeze the tips against the sponge or fiber tool from the tip maintenance station to achieve proper spacing and alignment prior to final tightening of the set screws. The tip tool can also be used for this purpose. The tips should now be in alignment and parallel when brought together. For larger PLCC tips with alignment slots, make sure that the tips are fully inserted into the heaters. Then insert the tip alignment tool into the slots and bring the tips together like this. While continuing to hold the tips together, gently tighten the heater set screws. The tip should now be in perfect alignment. If necessary, loosen the hinge screw and readjust the tip's ends as described before. The tip gap adjustment lets you choose the proper spacing between the tips to suit your particular application. The tip gap must be wide enough to allow the tips to just pass easily over the component, but narrow enough to avoid contact with adjacent components. The proper tip gap adjustment provides maximum convenience and safety, especially on high-density circuit boards. Next, in Part 2, we'll learn how to select the proper tip for your particular application. A wide variety of standard and custom ThermoTweez tips are available to suit many different surface mount removal applications. There are two-sided tips for chip components, SOICs, SOJs, and others. There are four-sided tips to remove J-leaded PLCC components, PQFPs, and leadless ceramic chip components, or LCCCs. There are also special thin-walled tips for leadless components, found on micro-miniature pager boards and other high-density assemblies. Tips are also available for removal of extra-large extended lead devices, such as this 304-lead PQFP. These tips let you remove the tiniest chip components safely. For further details on available tips, consult the latest revision of the PACE Tip and Temperature Selection System or the PACE Price and Parts books. To select the precise tip for your application, match the component you want to remove with the appropriate drawing found in the ThermoTweez section of the Tip and Temperature Selection System. Then follow the chart to the right and select the lead count or tip dimensions which match the specifications of the component. Finally, note the corresponding PACE part number of the tip for your application and install it in the ThermoTweez as described in Part 1. You may verify the approximate match of the tips to the component while cold, but tinning on the tips or component may affect the fit. Proper fit of the tips to the component is best verified during operation when the tips are heated to operating temperature and the tinning is molten. The heated tip should pass easily over the body of the component and contact all the leads at once when the tips are brought together. Make certain the hot tin tips contact all the leads at the same time, and be sure your component identification and tip selection are correct. As tolerances and specifications of components can vary greatly, proper tip selection is vital for safe component removal. You can often compensate for minor sizing differences by using the bridge fill method described later in Part 4. Otherwise, a custom tip may be required. If you have any questions regarding applications, please contact PACE or your local authorized PACE representative. Next, in Part 3, we'll learn how to select an appropriate tip temperature for your particular application. The tip and temperature selection system is a convenient reference for choosing a temperature for your application and provides other important information. Setting and maintaining a proper tip temperature is essential for safe, effective operation of your ThermoTweez handpiece. To set tip temperature, first turn the power on. If your system has an installed password, it must be entered first. The password will consist of a combination of keystrokes. Before setting tip temperature, first note the channel powering your ThermoTweez. Then press the channel select key until the LED for the channel powering your handpiece illuminates. To set tip temperature, press the tip set key and immediately enter your desired tip temperature using the scroll keys. On single-channel digital display systems, follow a similar procedure. On Sensitemp systems with a dial display, simply adjust the control knob for the channel powering your ThermoTweez to your desired tip temperature. As with any heating system, large surface mount tips lose heat much more quickly than smaller tips, causing the true tip temperature to be much lower than the set temperature. This difference in temperature is called tip temperature offset. PACE Sensitemp systems with digital displays feature auto tip temperature offset compensation, which lets you set and display honest, accurate temperatures for any size and type of tip. To assure the most accurate tip temperature, turn to the ThermoTweez section of the Tip and Temperature Selection System and identify the tip installed in the handpiece. For digital display systems, enter the tip offset constant, which corresponds to the installed tip, by first pressing the tip offset key, then the scroll keys until the correct value appears in the display. Now press the Set key and enter your desired tip temperature. The true tip temperature will appear in the display. For dial display systems, select a true tip temperature, then adjust the control knob to the corresponding dial setting. For more specific information on setting the tip temperature, consult the introduction of the Tip and Temperature Selection System or your handpiece manual. The ThermoTweez handpiece is designed to operate efficiently at safer, lower tip temperatures. For most surface mount removal applications, use the lowest tip temperature, which will provide rapid yet controllable melt of all the solder joints. To increase tip life and reduce the possibility of damage, begin with a tip temperature of 315 degrees Celsius or 600 degrees Fahrenheit. Adjust temperature as necessary to suit your particular application. On extra heavy multi-layer boards or boards with ground planes, it may be necessary to increase the tip temperature to achieve rapid, complete solder melt of all the joints. However, true tip temperatures over 400 degrees Celsius or 750 degrees Fahrenheit can greatly increase the risk of damage. Remember to always follow your organization's tip temperature guidelines for each particular application. Surface mount removal on extra heavy boards will be discussed later in Part 5. Next, in Part 4, we'll learn about handpiece, tip, and work preparation. When working on static-sensitive boards, be sure to follow all requirements of your organization's EOS ESD control program before proceeding. The first step is to examine the board and components to be removed for any signs of conformal coatings, heavy oxides, or contamination which can greatly interfere with heat transfer into the solder joints during removal. Using a PACE microsheen system or other appropriate means, remove conformal coatings before attempting to remove any component. See other PACE videos for more detail on removal of conformal coatings. A cleaner approved by your organization may be used to remove heavy contamination and oxides. An approved flux may also be used to break down surface oxides and aid heat transfer. It is also important that the board is free of excess moisture before attempting component removal. If necessary, gently dry the board by using a PACE Mini Thermojet handpiece at a low temperature, or by other appropriate means. Clean, properly tinned tips are essential for maximum transfer of heat to the solder joints during reflow and removal of a surface mount component. After the tips have reached a proper operating temperature, clean them with the fiber tool to remove old solder. Then use the sponge tool to remove any remaining oxides. Finally, tin the inside surfaces with an approved flux core solder. If the tips don't wet with solder, repeat the cleaning process and tin again. If tips still don't accept solder, the problem may be with the particular type of flux in the solder you're using. Try a special tip reconditioning process if approved by your organization. Once the tips are properly tinned, adjust the tip gap thumb screw so the tips are just wide enough to fit easily over the component. For safe, rapid removal, it is essential that the tips make good contact with all the leads at once to ensure uniform solder joint reflow. To further improve heat transfer or thermal linkage with all the leads, there are 3 distinct methods. These include applying flux, using a solder bridge fill, or using a solder preform. In most cases, applying an approved liquid flux or paste flux is sufficient. In cases where the tip is not making sufficient thermal linkage with all the leads at once, the solder bridge fill method is the safest, most effective means of improving heat transfer and can greatly speed up the removal process. Solder bridge fill is the preferred method with large extended lead devices, such as this 208 lead PQFP. Using a heated soldering or desoldering tip and large gauge flux core solder approved by your organization, apply solder across all the joints like this until every component lead is bridged together with solder. Then proceed with removal. Solder bridging assures rapid, even heating of all the joints at once, virtually eliminating the risk of damage. The third method of improving thermal linkage is to use a solder preform. With large gauge flux core solder, form a loop tightly around the component to be removed. Then trim off excess. Applying additional external flux will further aid heat transfer. Before proceeding with removal, it may be necessary to open the tip gap adjustment so that the tips pass over the solder preform before grasping the component. It is also possible to use solder paste to improve heat transfer during component removal. However, use extreme caution because solder balls may be produced, which could cause short circuits if not thoroughly cleaned off the board. Next, in Part 5, we'll learn basic technique for removing components with the ThermoTweez handpiece. In Parts 1 through 4, we covered setup, tip selection and installation, setting tip temperature, and preparation of the work, handpiece, and tips. Now we're ready to remove a component. To begin, bring the handpiece and tips straight down over the component, staying at right angles to the board. Then gently squeeze the tips together, making good contact with all the leads. Avoid contacting the component body, substrate, or adjacent components. If necessary, readjust the tip gap. The goal is to evenly heat all the solder joints to reflow in a rapid yet controlled fashion before lifting the component. Complete solder melt of all the joints can be observed visually or by the component yielding to a very slight movement. Never apply force or lift the component before complete reflow. Otherwise, you may cause damage. When all of the joints have reflowed, the component can be lifted off easily. Move the handpiece over a burn-proof surface and release the component. Follow this same method for all other 4-sided and 2-sided components. If you don't get rapid, complete reflow of all the solder joints in about 3 to 5 seconds, remove tips, rotate 90 degrees, and try again. This technique helps evenly distribute heat when very high thermal mass joints are present. If you still don't achieve complete solder melt quickly, remove the tips and try one of the methods described in Part 4 for improving thermal linkage with the component leads. You may also increase the tip temperature to within your organization's guidelines or maximum safety limits. For extra heavy boards with ground or voltage planes, or on ceramic or polyamide assemblies, preheating the assembly using a PACE hotspot set at approximately 100 degrees Celsius or 212 degrees Fahrenheit will greatly speed up the removal. If you are still having difficulties, check to see if there is a conformal coating on the board interfering with heat transfer during reflow, or an adhesive underneath the component preventing removal after reflow. Review Part 4 and other PACE videos for conformal coating removal methods. For components bonded with adhesives, use the bridge fill method. When all the joints have reflowed, use curved tweezers to pry up a corner of the component. After removing a component, contamination left on the lands and old solder should be removed before replacement of a new component. See other PACE videos for safe, effective methods on removing old solder from surface mount lands. Next, in Part 6, we'll learn important regular maintenance for your ThermoTweez handpiece. During the workday, always keep your tips clean and tinned with fresh solder, especially before placing the ThermoTweez in its cubby. Tips should be examined periodically for wear and their ability to be tinned with solder. Worn or damaged tips, or tips that won't hold solder after repeated attempts to clean, re-tin, or recondition, should be replaced. To maintain optimum heat transfer and proper tip grounding, periodically remove the tips. And clean the heater bores with the supplied 3/16" wire brush while the heaters are hot. When work is over, remove your cleaned tin tips and store them in their ready racks. Place the ThermoTweez into its cubby and turn off the power. There is an endless variety of other applications you can perform with the ThermoTweez handpiece and PACE's extensive selection of standard and custom tips. For other assembly and repair applications, such as surface mount land preparation, through-hole soldering, desoldering, surface mount installation, and removal of other surface mount components. There are a wide range of Sensitemp handpieces and techniques which are presented in other programs of the Sensitemp Systems Video Manual series.
If you have any further questions on a particular assembly or repair problem, feel free to contact us or your local representative. Our product applications and training departments are happy to help. On behalf of all of us here at PACE, we'd like to thank you for joining us and look forward to seeing you again soon in the PACE Center classroom.